Hi, Assalamualaikum. My name is INSYIRAH binti MURNI. My matric number is D202311079950.
Hi, my name is SYAFIQAH binti ZAINODIN and my matric number is D202311079906.
Assalamualaikum warahmatullahi wabarakatuh. My name is NATASHA binti ZAKARIA and my matrix number is D202311079913.
Hi everyone, my name is NURUL FAQIHAH binti SUHAIMI. My matric number is D202311079943.
Hi, Assalamualaikum. My name is AUNI binti HARIFIN and my matrix number is D202311079949. Okay, for today we will teach you about limit and continuity. We go through the limit first. Limit is a fundamental concept in the calculus that is used in the definition of continuity, derivative, and integrals. The idea of limit is essential to analyze the change of a function values as the independent variable approaches a given value. Here is how we can pronounce the limit. The value of fx can be made as close as we like to L by taking x sufficiently close to C but not equal to C. Then we write it like this. So we can pronounce it as the limit of fx as x approaches C is L, or fx approaches L as x approaches C. In this video, we let you know about some of the theorem that we use from the limit topics. So here, we use the theorem of special limits. Special limits theorem are a set of rules to evaluate certain limits. They are special because they tackle limits that can't easily be evaluated by any of the usual methods. In a way, they are shortcuts to dealing with specific form of limits. Another method that we use is the conjugate method. The conjugate method is used for evaluating limits that contain radicals. Conjugates are particularly useful in evaluating some limits because they allow us to eliminate radicals. Due to its limited scope, you should use this method after you have tried the direct substitution method. We are not only use the terms or concept in limits, but we also use some terms or concept from another topic that is relevant to use it here. So, the concept that we use is quotient identities in trigonometric identities. The quotient identities defines the relation for tangent and cotangent in terms of sine and cosine. Later, you can see that we use this tan x is equal to sin x over cos x as part of the step in solution. So, what is continuity? Continuity, a process is one that takes place gradually, without interruption or abrupt change. In mathematics, continuity has much the same meaning. A continuous function means the graph of the function has no break in it. The graph of a continuous function can be drawn without removing your pen from the paper. Here is the graph of continuous function, and here is the graph of discontinuous functions. Okay, now I will explain to you about the type of continuity that we use in this video. The type of continuity that we use in this video is the continuity at a number. So, for the definition, a function f is said to be continuous at x equal to c, provided the following conditions are satisfied as shown below. First, fc is defined. Second, limit of fx as x approaches to c exists. And the limit of fx as x approaches c equal to xc. If one or more of the condition of this definition fails to hold, then we will say that f has a discontinuity at x equal to c.
So, our first question stated that limit x approaches a minus 9x over set a minus 3 set x equals to 4 set 2. Find the value of a. First, let's simplify the expression inside the limit. We can rewrite it as limit x approaches a A minus 9x over ZA minus 3ZX. Next, let's rationalize the denominator by multiplying both the numerator and the denominator by the conjugate of the denominator, which is ZA plus 3ZX. This gives us limit x approaches A minus 9x multiply ZA plus 3ZX over ZA minus 3ZX multiplied to ZA plus 3ZX. Simplifying further, we get limit x approaches A minus 9x multiply A plus 3ZX over A minus 9x. Now, we can cancel out the common factor of A minus 9x. Then, we can substitute A into x and we get A equals to 2.
Our second question is to find limit tan 7x over sin 3x, which is x approaches to 0. What we can do first? First of all, we can try to substitute 0 into the function. So, when we try to substitute 0 into the function, it will become 0 over 0, which is intermediate form. So, we can use the other method to solve this question. So, we cannot simply substitute 0 into the function. What we can do, we can use trigonometric identity, which is one of the trigonometric identity is tan x equal to sin x over cos x. So at this point, we can use trigonometric identity. So tan 7x will become sin 7x over cos 7x. Next, we can multiply cos 7x with the denominator, so it will become sin 7x over cos 7x multiplied with sin 3x. Next, what we can do, so at this part, we can change a little bit to make it become a special limit. So as we know, one of the special limit is sin x over x equal to 1. So at this part, which is sin 7x, we can change it a little bit to make it as special limit. So we change sin 7x become 7x multiplied with sin 7x over 7x. I know that most of you must curious why sin 7x become 7x multiplied with sin 7x over 7x. So let me explain why sin 7x become 7x multiplied with sin 7x over 7x. Because when we cancel 7x at denominator and the 7x at the outside, it will become sin 7x. So it will become as same as before, which is sin 7x. So we change sin 7x become like this because we want to make it as special limit. So sin 7x over 7x will become special limit. So we can make this equal to 1. We can do the same at denominator, which is sin 3x. As just now, we want to make sin 3x to become special limit 2. So we change it like before. So it will become sin 3x over 3x multiplied with 3x. So sin 3x over 3x will equal to 1. So it will become 7x over 3x multiply cos 7x. Solve this question easier, we can separate this equation become two parts, which is 7x over 3x multiplied with 1 over cos 7x. 7x over 3x. So we can cancel x at numerator and x at denominator. So it will become 7 over 3. And then to make us more easy, we can put 7 over 3 to the outside. So it will become 7 over 3 limit 1 over cos 7x, which is x approaches to 0. So at this part, we can substitute 0 into the function. So 1 over cos 7 multiplied with 0, it will become 1. So 7 over 3 multiplied with 1 will equal to 7 over 3. So the answer is 7 over 3.
Hi, my question is to determine whether the following function are continuous at x equal to 2. As we know, there are 3 rules to satisfy the function are continuous or not. The first rule is we need to define function of x at x equal to 2. So the first step is we need to factorize the numerator, which is x squared minus 4 to x minus 2 multiplied by x plus 2, and we can cancel out the same numerator and denominator. Then we can substitute x equal to 2 and simplify. Then we can get function of 2 equal to 4. So the rule number 2 is limit fx, x approaches 2 must be exists. So the left hand side is limit x squared minus 4 over x minus 2, x approaches 2 negative. Then we can factorize and simplify the numerator and denominator. Then we get a limit x approaches 2 negative equal to 4. Then for the right hand side, we use a limit x squared minus 4 over x minus 2, x approaches 2 positive. Then we factorize and simplify. Then we get a limit x approaches 2 positive equal to 4. So the right hand side and left hand side will equal. So the limit fx, x approaches 2 will exist. So we already know that the value of the limit fx, x approaches 2 and function of 2 is 4. So we can conclude the function is continuous at x equal to 2.
Okay, now I'm going to explain about this question. Okay, this question is an example of piecewise function. So let's move on to the question. Okay, the question stated that the function f is defined for all real x, and it's already given us two functions and have two range, which is x less than 2 and x is greater than equal to 2. Okay, the question asks us to evaluate limit of x approaches to 2, and since the question is already stated that the function is defined, so that's mean the limit is exists. So the right limit and the left limit is equal. Okay, for the first step, the easy way to understand and solve this question is by doing a number line. Since there is only one value of x at the range of on both function, which is x is 2, so we can draw a number line that consists x is equal to 2. Then make a dot line on 2. So we can see that the range x less than 2 is on the left and x greater than 2 on the right side. Okay, for the second step, we can identify the left limit and the right limit. From this number line that we draw, we can conclude that the first function that the range is x less than 2 is the limit x approaches to 2 from the left, and the second function, which is x greater than equal to 2, is the limit x approaches to 2 from the right. Okay, for the third step, let's focus on the first function. Okay, from the first function, we can factorize the equation. We can factorize the denominator into x minus 2 and x plus 2. To simplify this function, we also need to factorize the numerator into negative x minus 2. So we can simplify this function by cancel out x minus 2 from the numerator and x minus 2 from the denominator. Therefore, limit x approaches to 2 from the left is equal to negative 1 over x plus 2 after we simplify the function. Then we can just straightly substitute 2 in x. Therefore, the function is equal to negative 1 over 4. Okay, let's move on to the fourth step. For the fourth step, let's move on to the second function, which is limit x approaches to 2 from the right. For this function, we can just straightly substitute x equal to 2 in the x. So therefore, the answer is negative 1 over 4. If we substitute it with 2, then we get 0 over 0, which is 0 in the numerator and 0 in the denominator. which is it is a intermediate form, so we need to multiply the function with the conjugates. Therefore, we can conclude this equation, which is limit fx as approaches to 2 is -1/4.
Thank you for watching.
Bye.